Hi, my name is Kenny. I'm a sophomore at NYU Shanghai, and I'm studying mathematics and computer science.
Hi, I'm Quan. I'm a sophomore at NYU Abu Dhabi right now, and my major is mathematics.
Cool. So our project name is called MicroMail, and the idea is to make a Chrome extension that can automatically summarize your emails for you. So the problem we're trying to solve is the one of information overload in today's society. There's tons of emails that people get every day, and some of them are extremely long, and most of us just don't have the time to read all of them. So our solution is to create a Chrome extension that operates in your inbox. It automatically summarizes all your emails for you, so it takes 30% of the time or 50% of the time to get through all your emails. And the way that we do this is using some machine learning techniques. Essentially, the task is to just pick out the most important sentences in the email and display only those to the user. To start, we'll give you a quick demo of our algorithm and Chrome extension in action. Our extension lives in the Chrome toolbar. If you click on the MicroMail icon, a pop-up will come up and you can click the Go to Gmail button to take you to Gmail. Gmail will then load and you can use the extension inside Gmail, which we'll show next. So now we're inside Gmail and we can first search for an email to summarize. So let's look for an email from our machine learning professor. Once it loads, you'll see a summarize button in the toolbar. And if you click it, it'll automatically summarize the email by highlighting the most important sentences. As you can see, it highlights the homework, the final project percentages. It tells you the length of your presentations and the date that the presentations are due. So it does a fairly good job. And you can actually go into the settings of the extension and adjust the length of the summary. So let's make it longer. If you click summarize again, it'll summarize a much larger portion of the email. You can also make it much shorter. And now it'll only highlight a few of the most important sentences. You can also change the summary type. So if you click show, it'll only show the summary instead of highlighting. And this might be easier to see if we choose a shorter length summary. So let's make this shorter. Click summarize again, and you only see the most important sentences in the email.
So the dataset that we use is called BC3 training corpus, and it's taken from a master paper created by a student at University of British Columbia. In that corpus, we have 40 email threads consisting in total of 3,222 different sentences. The way we take in the corpus is that each sentence is vectorized into a feature vectors with the features that we'll talk about later on. And the way the way that the summaries are determined is that there are 3 human annotators each separately select the most important sentence out of these 40 email threads. And then the score, or how important a sentence is the number of annotators that pick that specific sentence. So it ranges from 1 to 3. However, we also do normalization on the score of the sentences that we'll talk about later. There are also additional metadata such as the date of the email, the name of the email, how many reply, is there a CC. So the BC3 corpus is presented to us in an XML file format. And if you look into the slideshow right now, you see the structure of the XML file. There is a root tag, which consists of the 40 email threads. Each email thread is represented by one thread tag. In each of that thread tag, you can see the metadata, such as the name of the email threads, the name of the email of the first email. Within each email thread, there are different emails, and then within each email tags, there are different tags that which is sent for each sentence, and the different kind of metadata that you can explore on the slide. With regards to summarization, we do extractive summarization. There's 2 kinds of summarization. There's abstractive and extractive. Abstractive, generally very much more difficult, which is the algorithm try to learn what the email means and then summarize the meaning of the email. However, for extractive, the algorithm determines which are the most important words, or in our case, which are the most important sentences, and picks out those sentences to represent the meaning of the email. For each sentence, a sentence is represented by a features vector. We use 14 features in our training, and Kenny is going to talk about the specific features later. For the algorithm, we use a decision tree algorithm called regression-based random forest. And after we have trained the algorithms and classified X sentence in the email according to how important that sentence is. The summaries are determined by a sorted list of sentences in terms of the importance of each sentence, and then determine on how long do we want the summary to be. We'll pick out, for example, the top 10% or 30%, which is a standard of the sentences at the top.
So our approach to this problem has 5 major steps. The first is parsing the email. So we take the raw HTML or raw text of the email and split this into sentences. And this was actually a much harder task than we imagined, because sometimes periods and commas and stuff, they don't actually delimit sentences, but people just use them in phone numbers or emails or stuff like that. So we had to tackle all of these edge cases when figuring out the sentences in an email. The second step was actually vectorizing these sentences. So we would take each sentence and calculate 14 or more features based on the sentence and turn those into a feature vector. And after that's done, the third step is to feed these feature vectors and also the human annotated labels into a regression-based algorithm that was random forest. And based on the output of this, we can order the sentences based on their importance, based on the importance score that the classifier outputs. And number 4 is pruning of the sentences. So after we sort the sentences by importance, we can actually shorten each sentence further by using natural language processing to get rid of adverbs and stuff like that. And the 5th step is actually taking these sentences and displaying them back in the correct position in the original email so that it doesn't disrupt the flow of the email. And this was also a much harder problem than we envisioned, mainly because it's actually very hard to deal with all of the HTML tags. So right now, our Chrome extension only can really handle plain text emails or very light HTML markup emails. But if we wanted to do something that works for all emails, so something that you might get that has a lot of pictures or graphics and formatting, that will take a much more complex and robust solution. So the feature set that we started with is called the R14 feature set. This was created by a paper at Columbia that looked at the problem of email summarization as well. And basically, these features are split into 2 different types. One is text features. So these are features that are based on the actual words or the actual sentence. And also email features, which is primarily based on the email position or email features in the thread. So for example, we have text features such as the line number in the thread, the position of the sentence in the thread. We have the length of the email, and also if the email is a question. We also do some things with TF-IDF. There's 4 features that are based on TF-IDF, so it's a very important measure, and Quan will talk more about this in a bit. And for some of the email features, we have stuff like the number of the email within the thread, the number of recipients of the email, how similar the email subject is to the current sentence, and all these different features.
So one really cool feature that we thought we'll go more in depth with is TF times IDF. It's a feature that are very widely used across different sections of machine learning in determine how important a word is within a paragraph. The relevance of this in our specific case of email summarization is that we are picking out important sentences, and the intuition is that if a sentence contains many important words, then it's probably a very important sentence. So how do we determine a word is important? If a word, the intuition behind term frequency is that if a word appears many times throughout the email, then that word is probably important because it's used repeatedly. However, there are also words that are used repeatedly but are redundant, such as the, and, or many stop words. And hence, the term frequency has to be normalized by the inverse document frequency to remove the cases where there are terms that are used very frequently in the email, but also used very, very frequently throughout the whole email threads or throughout the whole documents. And that's how we determine how important a word is to understanding an email.
So in addition to the R14 features, we actually included some of our own custom features. So we'll go through some of these in this slide. The first is hasDate. This is pretty simple. So it's a binary value. We give 0 or 1 based on if the sentence has a date inside it. The next 2 features are hasPhoneNumber and hasEmail address. These are not as simple as hasDate because we actually have to normalize this. And this is due to the problem that we see with email signatures. So people generally like to put their email address or their phone numbers in email signatures, while this is not necessarily important information. However, if an email is in the body of an email, such as someone saying, please email this email address, that's probably very important. but it's hard for the classifier to distinguish between the two if it's just a binary value. So our solution is just to normalize this value based on the length of the sentence. That means we multiply 1 by the length of the sentence if it has a phone number or email address, and it's 0 if it doesn't have either of these features. So basically, a sentence in the body of the email that has a phone number or email address will have a much higher score for this feature versus a sentence that has an email in the signature of the email. We also use the number of I's and U's in the sentence. We count the number of verbs, and we also count the number of uppercase words in the sentence.
So some of the specific module that we use, Python modules that we use in this project include skitlearn. That's where we get the random forest from. We use natural language TK for stemming word, reducing words in sentences to their stem forms, and removing adverbs, because NLTK provide a very handy function that it tags each word in the sentence of what function that word serves. We also use date util to detect if there is a date in one sentence. We also use regular expression detection to split sentences, because as Kenny have mentioned earlier, there are cases where period or comma are used for phone numbers or emails, and we don't want to split that. We want to split at the end of a sentence. So if you look into the slideshow, you see the specific regular expression term that we use to detect when we should split. We also use the XML function, the modules to pass and to get the data from the BC3 corpus.
So the way we evaluate computer-generated summaries is with a measure called weighted recall. And this is based off something called the pyramid method, but slightly simpler. And we only use recall in this measure instead of precision, because for precision, the length of the summary that we choose will greatly affect the precision by nature. So it only really makes sense to look at recall for a summary. And basically, the way weighted recall works is we take the sum of the score of the sentences. So the score is defined as the number of annotators that select a sentence. So for the BC3 corpus, that's a number between 0 and 3. So basically, for weighted recall, we take all the sentences in the summary. We look at the score of all the sentences in that summary that the classifier chose, add that up, and divide that by the sum of the scores of the summary that the human annotators chose. And the larger the percentage is, so the higher the score is compared to their score, the better our summary is. And the results we got were about 45% weighted recall compared to the paper, which was around 65%. For whatever reason that we're not really able to determine right now, we were unable to replicate the paper's results, but we'll be looking more deeply into our code and trying to debug things further. So now I'll talk a little bit about how we got the extension and the server working. So our extension is just a browser action Chrome extension. That means it has a button in the Chrome toolbar, and it runs with the persistent background script and also some injected scripts into the page. So the main UI to the user is just the extension pop-up. So if you click the button in the toolbar, it'll show you a pop-up that you can change the settings and also go to Gmail. There's also a button in Gmail that will help you summarize the email. So our extension communicates with our server, which is running on Flask with Python on Amazon's EC2 servers, and basically just transports data back and forth with JSON. And we also have the script request the summary immediately after the user opens the email rather than right after they click the summarize button. This helps reduce perceived latency because our classifier takes 1 to 2 seconds to find the summary and return it to the client. Additionally, to optimize this, we don't generate the random forest tree classifier object every time. We actually pickle this object on the server and just load it every time we need to call it. And this makes it much, much faster. Additionally, our server doesn't store any data about the emails that come in, but this is still over insecure communication. It's just HTTP, and this is not really ready for mainstream usage yet. It'll take a lot more security measures because we don't want people to be sending their personal and perhaps confidential emails to an insecure server. So if you look on this slide, this has basically the JavaScript code that runs on the client that sends a request to the server for a new email. That's the IP address of the server you can see there, and basically it just sends the entire email data along with the recipient and the subject of the email to the server. This next slide shows the Python code that's running on our server, and it's very simple. It just takes a request from the client. So when the JavaScript sends the email data and the metadata to our server, it gets all of these from the request, and then it calls our classifier function. It gets the summary that's output from the classifier and sends it back to the client.
So our future work includes, the first thing in our future work include trying additional features for the sentences and see if that include the result, the weighted recall score of our classifier. The first feature include HTML markup, things like if the sentence of the word is bold, underline, italics, and see if that has any bearing on the importance of the sentence. Also email data, metadata, such as if the sentence is referring to the email that the sentence is in, if maybe that's a more important sentence than the rest of the sentences. Also speech acts. Speech acts are terms on the meaning of the sentence that define the purpose of that sentence. For example, a sentence can be used to schedule an event, to order a person to do something, or to change the schedule of event, and maybe these are more important than the other sentences in the email. We also want to try to implement, because right now the dataset doesn't allow it, but we want to go more granular into the sentence. What that means is that we want to have features that are deeper than the sentence level, because right now our smallest feature is based on a sentence. So we want to try to go into words and phrases and see if that has any bearing on the importance of the sentence.
Additionally, we want to implement more accurate email and sentence parsers. So right now, our regular expression for finding the sentences in an email works pretty well. It doesn't work sometimes. We still get some degenerate sentences that are just empty strings or a few characters, and we have to kind of tweak those and find the bugs in that. Additionally, we want to add some user feedback buttons for the summary. So if a user doesn't think our summary is very good or thinks it's very good, they can send this feedback to us, and we can use this to help improve our regression classifier. Lastly, we also want to implement some feature based on user feedback of how to automatically choose the length of a summary. Basically, we don't want the user to manually have to toggle the slider to adjust the length of the summary. It would be great if our program could actually do this automatically and choose the best length.
Thank you for listening.